Hello and welcome to this short tutorial on how to use the motor yield calculator in KellyDown. The motor yield calculator is used to calculate the slide distance required when drilling a section of hole in order to achieve a specific dogleg rate given the slide length, rotate length and resultant dogleg rate over a previously drilled section of hole. However, it is actually much more than a simple motor yield calculator when used in conjunction with the slide sheet editor and either the correction run module or the Ouija board module. First, let's look at using the motor yield calculator in its basic form by launching it from the survey editor in KellyDown. We're using well AA16 run number 4 from the example database to show this example. So from the survey editor, click on the motor yield button. And you'll see that the motor yield calculator opens up with the values that we used in a previous session. So let's say that in a previously drilled section of hole between two survey stations we slid for 15 feet and we rotated for 75 feet. And over that section of hole we observed a dogleg rate of 1.75 degrees per 100 feet. And you can see that the motor yield over that section is calculated as being 10.5 degrees per 100 feet. If we move down and we know the distance of our next stand that we're going to drill, and let's say that's 88.75 feet long, and we wish to achieve a dogleg rate of 3.5 degrees over that section. So enter 3.5 degrees for the required dogleg rate, and you see that we need to slide the BHA by 29.58 feet over that stand length of 88.75 feet. That's 33% of the stand needs to be slid. Now let's close the survey editor and open the motor yield module from within the slide sheet editor. So close the motor yield module, the survey editor, and then open the slide sheet. And then open the motor yield from within the slide sheet. And you'll immediately see that the slide length has been transferred from the two slide intervals in the last surveyed section of hole, and the rotate length has also been transferred from the last surveyed section of hole. And also the dogleg rate is taken from the slide sheet as well. And you can see that the motor yield is 7.864 degrees per 100 feet. And then if we enter the same values for our next stand length of 88.75 and we want a dogleg rate of 3.5, and we see that the slide distance over our next stand is 39.49 feet, and that's 44% of the next stand length. So now let's see what happens when we open the correction run module from within the slide sheet. So go to the slide sheet, click on the correction run module, and you all know that the correction module is used to correct the survey data back to the well plan given a particular dogleg rate, a course length or a corresponding measure depth on the well plan. So let's enter 3.5 degree per 100 feet dogleg rate to correct back to the well plan. And let's open the visualizer and look at what this correction dogleg rate has done. So on the visualizer you can see the survey data in red, the bit projection is in purple, and the projection back to the well plan is in magenta. And KellyDown has told us that using a 3.5 degree dogleg, the course length required to get back to the well plan is 342.7 feet. And we need two curve sections to return back to the well plan. So what happens if we open the motor yield module from within the correction run? And you can see that KellyDown has transferred that first course length to the stand length on the motor yield module and has transferred the 3.5 degree doglegs. And it's also telling us that we need 85.89 feet of slide in that first section, and that's 44% of that total stand length. And in the grid below we have our bit projection, which is at 5046 feet, and then there is a curve, hold, curve section. So we've got the motor yield, which is 7.867 degrees per 100 feet, then a straight section, and then another 7.867 degrees per 100 feet curve. And you'll notice that the sum of these first three course lengths is equal to the course length of that first build turn section in the correction run module. And then the bottom three lines in the suggested slide rotate correspond to the second curve section from the correction run. The 33.29, the 83.07 and the second 33.29 values equal the course length of 149.65 taken from the correction run. Once again, we've got the 7.867 degree per 100 feet dogleg, and the tool face values are also taken from the correction run. And when we click on the motor yield, the visualizer shows the track of the correction calculated by the motor yield module. If we click back on the correction run module, you can see this is the track calculated directly from the correction run. And click on the motor yield, and this is the track calculated from the motor yield module. Similarly, if we open the Ouija board module from the slide sheet, we enter a 3.5 degree dogleg rate, and we want to hit the center of AA16 TD target. And KellyDown tells us that we need a course length of 74.17 to turn the well towards the target, and then we have a 725 foot straight section to hit the target center. And now if we click on the motor yield button, this information is transferred to the motor yield module. So our current bit projection depth is 5046.68, and then we have a curve, hold, curve section. The dogleg rates match the motor yield calculated from the slide sheet, and the tool face values for the slide sections match the tool face values calculated by the Ouija board. And then there's a 725.27 foot course length to hit the center of the target. Let's look at that on the KellyDown visualizer, and you can see the curve, hold, curve section to turn the well towards the target, and then the straight section to hit the target center. As with most modules in KellyDown, there are options to produce a report, perform anti-collision on the projection, and to view interpolations of the projection. So go to the motor yield module and click on the View Report button, and you'll see a report showing the last 5 survey stations, the projection to the bit, the turn towards the target plane using the motor yield dogleg rate, a straight section and another motor yield dogleg rate, and then straight projection to the target. Click on the Interpolations button to view interpolation, and as with all interpolations in KellyDown, you can enter any depth from the surface down to the end of the target projection. So our current projection is at 5846 feet, and we can also enter a depth of 100 feet. Also, one thing worth noting about KellyDown is it doesn't just show you the first value that matches the criteria. For instance, if you enter an inclination of 90 degrees, KellyDown will find all the depths in KellyDown where the inclination is exactly 90 degrees. The same with azimuth. If I enter a 65 degree azimuth, KellyDown will find all the depths where the azimuth passes through 65 degrees. You may also run a proximity scan against the projection to the target, or view the vicinity of other wells that are close to the projection. Click on the Quick Scan module, select Traveling Cylinder, Last Survey, and you can see the other wells which are in close proximity to the projection that you're drilling at 5846 feet. Thank you for watching this tutorial. For more information, please visit www.kellydown.ca.